In a 60-degree angle prism with mu equal to 1, the condition for minimum deviation is fulfilled. So this, what the condition? So if there's a base, we know at minimum deviation the refracted ray will be parallel to the base. Okay, then let's directly get into the, let's read the question. In a 60-degree angle prism with mu equal to 1.5, the condition for minimum deviation is fulfilled. If face AC is silvered, find the net deviation. First minimum deviation is there. Now I'm going to silver it. Then he'll ask you the deviation. Then he'll immerse this in water. Then he'll ask deviation. So all three parts are there. They're the first part of the problem. So we'll calculate these angles now. This is I1, R1, R2, R2. We know at minimum deviation, I1 should be equal to I2 and R1 equal to R2. R1 plus R condition is, and we have one more, R1 plus R2 equal to A. So can we get I1? Sin I1 equal to mu sin R1. Mu is how much? 3 by 2 sin 30 degrees. So I1 will get the 37 degrees is what will get the I1 value. Three by 4, 48, sorry. 48. I took calculator, using scientific calculator, I'm able to predict this value. Okay, keep this I1. Okay, next is asking, now if face AC is silvered, find the net deviation. This is one part of the question. If face AC is silvered, find the net deviation. Say under same circumstance, only the face AC will be silvered. This angle is 60 degrees. Degree angle prism. So this angle will also be 60, 60. So first we'll write all this data. This side is silvered. Okay, fine. So now it will be, so the angles incident is same. There won't be change. I1. This will be R1. It's a mirror R2, R3. This will be I3. So what are the relationships now? R2 plus R3 should be equal to 60. R2 plus R3 should be equal to 60 degrees. So here, R2 plus R3 should be equal to 60 degrees. R1 plus R2 is 60 degrees. We know R1 30 degrees, so we know R2 is also 30 degrees. So as we know, I'll write it here. 30 equal to, therefore R3 equal to 30 degrees. And we know R2 plus R3, we got it. So we'll calculate I3 now. Now mu sine R3 is equal to, mu is how much? 3 by 2 sine 30 sine I3. So we have to calculate again. I3 will be 48 point. This is very important. These two angles will be same. Hmm? Okay, now he's asking deviation. Deviation L, M, N. The net deviation should be equal to deviation at L, M plus N. Deviation at L, I1 minus R1. Deviation at M, here. Angle of incidence minus angle of reflection. Deviation will be 180 minus 2R2. Deviation at N, angle of refraction minus angle of incidence. I1 equal to I3, we have 2I1. So we know R1 plus R2 is 60, no? 60 degrees. R2 plus R3 is also 60 degrees. Negative sign. So solving this, we'll get the deviation. 2 I1, I1 48, no? So 48.6 degrees. So net deviation, we'll get it as 157. 48, 48, how much will be? 106, 107, 157. Okay, this will be your answer. Next again, if it is same thing, if it is immersed in water, all the relationship will remain same. Only thing is that I1, I3, everything we have to, the angle of incidence will be same. I think the Snell's law here will change. Here it will change, no? Sine I1. So here mu W sine I1 equal to mu sine R1. The next part of the problem. Find the net deviation. Now the prism is immersed in water. Find the corresponding net deviation is asking. Uh-huh. So here then what we'll do is like mu will get added up here. This I3 will change. Okay, we have to go for the next part of the problem. I have to immerse in water, no? The prism, now I'll bring the prism. And the same silver conditions will be there. Okay, the ray will be incident. The same angle I1, R1. The angle will not change, only here R2, R3. This angle will change. I'll write theta. I1 will be as it is, huh? Mu W it is. So the net deviation will be I1 minus R1, 180 minus 2R2 plus theta minus R3. So this will be I1 plus theta minus R1 plus R2 plus 180 degrees. This deviation is asking delta dash and write it. Theta is what we should find out. We know all the values. So how to calculate theta? Mu sin R3 equal to mu W sin theta. Mu is 3 by 2. R3 value, R3 is how much? 30 degrees. Mu is 4 by 3 sin theta. So 9 by 16 equal to sin theta. This value of theta will substitute. So this will be net deviation. So I1 will be as usual 48.6 degrees theta. R1 plus R2 60 degrees. R2 plus R2 60 degrees plus 180. Okay, getting theta, substituting, so we'll get the deviation. I have sine inverse of 9, so net deviation will be, please check this, when prism immersed in water. The surrounding is the water. And this is silvered. And the complete problem, I'll show it. This is what we have discussed. See, you have to put effort. Nothing is there. You have to put effort. You have to draw the ray diagram first, then the geometry. Okay, afterwards, straight away, you can apply the Snell's law and some calculations. This should be the approach. I think almost this is a seventh problem I'm showing it here. So the first page number one, page number two, the method is very important. A student must have a confidence the what will happen to the ray, how it will trace out. If you know the ray, how it moves inside the prism, then comes the geometry, then Snell's law. I think the methodology is somewhere here. If any surface is silvered, it will act like a mirror. The silvered surface will act like a mirror. Angle of incidence should be called angle of reflection. If it undergoes TIR also, the condition is same. But you can't write sine R2 is